This video will be going over section 1.1, which is on angles. This is the first thing we study in trigonometry. The topics in here, you probably have some familiarity with angles from geometry class in high school or something, and you probably know angles as degrees, the way we measure them. But the very common way and necessary way in many problems is to use the measuring system of radians, and we'll talk about that. We'll also talk about degrees and converting between them, and I'll also just preface why we really need to use both depending on what you are studying. Then the next topic will be something called coterminal angles, and then the topic after that, reference angles. And then finally, what we'll see with radian angles when we do some examples is there's a pi with them a lot in their angle, like pi over 2 or just pi. But you can have radian angles that are just numbers without pi, and a lot of times when you start this trigonometry, this radian stuff, you don't get very comfortable with radian angles without pi. You want them to be degrees and as if there's a typo or something. So we're gonna have a brief little section on that as well. Okay, so like I said, the study of trigonometry begins by studying angles, and there are two common ways to measure angles. One that you are probably a little familiar with, which is degrees. A right angle is 90 degrees, acute angle is obtuse angles, and so on. And you might not be familiar with radians. Now, I'll go ahead and say the way this works. Most science classes will use degrees, and most math classes will use radians. The reason for this is degrees are an interpretive thing. If you tell me the angle of 45 degrees, in my head, I'm quickly thinking, okay, that's half of 90. A right angle looks like this, so it's going to be about half that. When we use radians, even for me, doing this for a very long time, if you just tell me 2 radians, you'll find out very quickly that's not going to mean a lot as far as interpreting the result. Right, so we do both. The reason why we have to use radians is virtually every single formula that has a pi in it, it's actually some type of radian angle, and it wouldn't work with degrees. Okay. All right, so like I said, most science classes use degrees, most math classes use radians. You want to get comfortable with both, but don't always go to degrees. Try to switch to degrees when you do problems. Try to get yourself a little more comfortable with radians as we go through. All right, now throughout this class, when we are referring to an angle, we want to have a visualization, and that visualization I have depicted down here. Right. So when we're talking about an angle, what we want to think about the angle as is being measured counterclockwise from the positive x-axis, like below. So I have quite a bit here written out. The common letter that we tend to use to represent an angle is the Greek letter theta. Looks like a 0 with a line in the middle. And when I'm thinking about this common angle that we're going to use, it starts at the positive x-axis. We will pretty much not draw this when we think about an angle, the positive x-axis, because it's already there. We're going to draw an xy plane, and we're going to understand it starting here. And like I have written in the green here, angles always start at the positive x-axis. We typically don't draw it because it's understood to be there. Now you have to draw another angle or another line coming from the origin so that you can form an angle between the two lines. And the other line is called the terminal side of the angle. And typically we will only draw this arrow to represent the angle. Right? We won't draw this one. If this green line was gone and I wanted to describe this angle, I would just draw this line. But the angle between the positive x-axis and that line is the angle we are talking about. Right? So what I also want to point out here, this is the angle. I have an arrow drawn starting from the positive pointing to our terminal side, the blue side. That's because this is the way we are going. Right? We're coming from the positive x-axis to wherever we are going. Right, so just to kind of put into perspective here, you know what a right angle looks like. We have a little box here. If you think about the x and y axes, this is a right angle here, so it's 90 degrees. You know, this angle might be something like 45 degrees if we were asked, because it's about halfway to the y-axis. Right, but just to give you a frame of reference. And then the other thing that we're going to use a lot throughout the class, and I wanted to go ahead and put it on this introductory chart, is the quadrants of the xy plane. So the top right, where x and y are both positive, is quadrant 1. And mimicking the angle, moving counterclockwise, we do the same thing with the quadrants. As you go counterclockwise, so as we go over here, we're in quadrant 2. Down here, we're in quadrant 3. And back around here, we're in quadrant 4. You kind of think about that counterclockwise motion, in case it's been a while, to think about how the angles go up. We're at 1 up here, and then we go around, increase to 4. Right, so this is a picture that also we're going to draw a lot, almost with every problem throughout the class. No, I shouldn't say almost every problem, but a lot of problems. I would guess probably 25% of the problems by the end of the class, you will have drawn an XY chart with the quadrants. Right, so as the above describes is how we will draw the angles. Written in the picture, we won't draw the starting line. I have also labeled the quadrants as a reminder. Hopefully you remember those, but if you don't, just get them memorized very quickly. Often we will refer to what quadrant an angle is in, which is very important. So this angle is in quadrant 1 because its terminal side is in quadrant 1. And that's exactly what I have written here. And just to make it easier on me, because we will refer to quadrants so much, instead of writing quadrant 1 or quadrant 2, I'll abbreviate a quadrant with Q. So we would say this is in Q1, Q2, Q3, or Q4. All right, so this next little picture, it's going to look a little overwhelming at first. I want you to just, I have both the degrees and radians picture. I want you to just look at the left side, which is the degrees first. It's going to talk about the quadrants, how the angles work with degrees, and everything else. Okay. All right, so the left picture is in degrees. One thing I'll point out here, you should be familiar with the degree symbol, which is, you know, that circle that looks like it's in an exponent. Yeah, so the degree here, picture here, once again, don't worry about this right now. We'll talk about this in a second. The degree picture here, there's a lot that looks like is going on here. It's not a terrible amount. So our angle of 0 degrees is the positive x-axis. Right, the reason it's 0 is because if this is our terminal side, we haven't made an angle, we haven't moved at all. So it's 0. Then if we go up to the y-axis, that's a right angle from the positive x to the positive y, so that's 90. And every time you go to the next axis, counterclockwise, you add 90 degrees. So we got 0, then 90, then 180, then 270. And if you go all the way around, you're back at 0, but it's the same as 360. Right, and you're probably familiar with, if you turn around, you rotate 360 degrees. So that's where that comes from. Right, one thing that's going to be important about the quadrants is just pointing out if my angle is a certain degree, if my angle is a certain radian, what quadrant is it in. These angles, 0, 90, 180, and so on, if you label them in your picture, you don't have to memorize too much. You can just look and compare your angle. So if an angle is between 0 and 90, it's in quadrant 1. If an angle is between 90 and 180, it's in quadrant 2. 180 and 270 is in quadrant 3. And 270 and 360 is in quadrant 4. Okay, once again, this is preliminary stuff, but you know, you could be asked pretty much only one thing based on this picture. If I give you an angle, what quadrant is it in, and you want to draw this picture. We will do plenty of examples. I'm not just going through notes here, I'm going to do plenty of examples, but I wanted this stuff at the beginning of the notes. All right, the picture here on the right is radians. And you'll notice one thing I have pointed out here is I have the angle starts at 0. Instead of 90 degrees, the radian is pi over 2. So I want to talk very quickly about where these numbers come from. Pi over 2 and pi, these are the decimal versions, which we'll get to later. But the whole way these radians come about comes from their circumference of a circle. You know the circumference of a circle. If we go all the way around a circle, the circumference formula is 2 pi times r. That 2 pi actually is the same as the 2 pi radian degree measure here. If we go all the way around, what we want to do is call that angle 2 pi radians. So that's where all this is going to come from, because 2 pi is the same thing as going around all the way around our circle. If we go all the way around our circle, it's also 360 degrees. And what you do just to figure the rest out is just go from there. If 2 pi is 360 degrees, then pi is where 180 degrees is. Pi over 2 is where 90 degrees is. And 3 pi over 2 is where 270 degrees is. Okay, so all these numbers here that represent the pi's are coming from this. Well, see, you pretty much just use this formula to convert between degrees and radians, which is what we're going to do first in a second. But you want to also really remember these things. So the y-axis is pi over 2, positive y-axis is pi over 2. The negative x-axis is pi, the negative y-axis is 3 pi over 2, and the positive y-axis is 2 pi. They both start at 0 degrees or radians because they haven't moved. Right, so once again, you will see when we work the problems, when I deal with radians, I'm going to label 0, pi over 2, pi, and so on for that reason. And these are just telling you what the angles are between. So between 0 and pi over 2, you're in quadrant 1. Between pi over 2 and pi, you're in quadrant 2. Pi and pi over 3 pi over 2, you're in quadrant 3. And 3 pi over 2 and 2 pi, you're in quadrant 4. The numbers beside are the decimals. If you just type in pi over 2 into your calculator and round to 2 spots, pi, 3 pi over 2, and 2 pi. When we get to that very last section dealing with radians without pi, these are the numbers you use because you just cannot compare things very well. For example, if I didn't tell you what 3 pi over 2 was as a decimal, would you know if that's bigger or smaller than 4 or 5? Where does it fit between? So that's why we are going to end up using those. But this little picture here is just me explaining where the 2 pi comes from, the circumference of the circle, as I already mentioned. If you want to pause the video and take time to look at this, or just look at it in the notes, you can. Right, but that's where radians and degrees interact. Now we're going to actually just work some problems converting between them using the formula. And one thing you'll see with the formula, it's very quick, but it would be easy to get it backwards, and I'll show you how to make sure you do not get that backwards. Okay. So to go from degrees to radians, you multiply by pi over 180. Right, so one thing I mentioned above here, which I have written as well, is 360 degrees is 2 pi radians. Well, if you just cut these numbers in half, you get 180 in pi. So that's where the 180 in pi come from. To go from degrees to radians, you multiply by pi over 180. You can also do 2 pi over 360, but you're going to end up canceling that 2 out every time. But one thing I will constantly encourage you to do is when you're dealing with degrees, you need to write that degree symbol. And you'll actually see when we do the problems, it helps a lot. All right, so that's to go from degrees to radians, we multiply by pi over 180. To go from radians to degrees, you just flip by the reciprocal. You multiply by 180 over pi. Right. Now this is, again, what I'm going to talk about. I'm going to say a lot, especially at the beginning notes of this course. If an angle does not have a degree symbol, then it is radians. If it doesn't have a degree symbol or written degrees in the problem, it is radians. You actually don't need to write anything after the number. So if I just write pi without a degree symbol, it is radians. And then the other thing, we will see that most angles measured in radians have pi, but it is not necessary. But the first thing, going one way, convert the following angles from degrees to radians. Your answer should have a pi in it, and any fraction should be fully reduced. Right, so we got 90 degrees, and we want to go from degrees to radians. Right, the way you can remember, if you remember the pi and the 180 thing, the way you can remember which one to do, when you multiply, the degree symbol has to go on the bottom of this one because we want them to cancel out when we divide. It's sort of like if you've taken some science classes and you cancel out the units, the degree symbol is sort of like a unit, like meters or something, and you want them to cancel out. And so we multiply by pi on the top because pi doesn't get a degree symbol, 180 does. That goes on the bottom. And just like I said, the units cancel. And if you multiply these and simplify 90, if it helps you, you can write it as 90 over 1. We multiply fractions here. We multiply the tops. We get 90 pi. Do not press that pi button in your calculator. Your answer should have a pi in it, so leave it alone. The denominator, 1 times 180 is 180. And now if you can simplify the fraction, go ahead and do that. And 90 over 180, we can simplify quite a bit. We can take a 180 out, or sorry, a 90 out, and we get 1 over 2. So our final answer is 1 pi over 2. And you can just simplify that and write it as pi over 2. But that's how we convert from degrees to radians. I'll remind you from the picture up here, 90 degrees and pi over 2 radians were the same. That's how we get it. All right, now, I just have one more here just to stress that, the angles don't have to simplify much if they're not very nice, and that's quite fine. So number 2 here, we want to do the same thing. We want to convert 602 degrees to radians. Okay, so for the same reason as last time, to think about getting the units to cancel, we put the 180 on the bottom and the pi on the top. So the degrees cancel. If you think about the 602 being over 1 again, because we're multiplying fractions, we get 602 pi over 180. Now, if you can simplify the fraction, you need to. These fractions are kind of big. So you might be inclined to do that in your calculator, but we can take a 2 out of each. They're both even. We got 301 over 90. And 301 and 90 have no common factors. So the 602 degrees is simplified to 301 pi over 90. All right, now one thing I guess we can mention here, this is a little preview as well. Your angles can be anything. They can be much bigger than 360. They can be negative. What will happen, which we'll see, is that we just keep going around and around and around. It's still going to be somewhere in here. But that's a topic called coterminal angles, which is the next thing. Right, now, converting from radians to degrees, right, going the opposite way. Right, like I said at the beginning here, you will a lot of the times have the word radian written in there, but this is not necessary. To convert from radians to degrees, think about having the 180 over pi, but this time if we want to get to degrees, we need degree symbol on the top. That's supposed to be a degree symbol. Of course, sort of looks like a little heart. We need a degree symbol on the top, meaning I'm going to put the 180 with its degree symbol on the top and the pi on the bottom. Now, one thing I will stress here is that if this doesn't have a pi in it, that's okay. It's still a radian, and this wouldn't cancel out. But when it does have a pi in it, you can just simply cancel the pi's out and see what we are left with. And this is 180 degrees. All right, so pi radians is equal to 180 degrees. All right, and just another one to complete it. 12 pi over 7 radians. We want to convert that to degrees. We got to make sure we have the degree symbol on top. That means the pi goes on the bottom. Simplify our pi's. If we're multiply the fractions now, 12 times 180. Yeah, definitely do that in your calculator if you feel like it. 2,160 over 7. And this fraction doesn't simplify. Right, so 2,160 over 7 is simplified. They don't have any common factors. You can check that in your calculator. 2,160 is a rather big number. So you can write your answer perfectly like this. Some people will say when you have a fraction with degrees, you need to put a parentheses around it. And that is not necessary to me. It's up to you. Just, beware that you can have the fraction for degrees, and that's fine. So either one of these is good. Right. But as far as going from degrees to radians, radians to degrees, it's pretty direct like that. So the next topic is coterminal angles, the kind of the thing I mentioned before here. What we're going to want to do is, if we are given an angle, we're always going to need to find out what quadrant it's in. It's really, really, really important to know what quadrant your angle is in. And that won't become very obvious until later in the section and the next section, but for now it is something that you need to know is going to be very important. Now, if you have an angle that's not in degrees, but it's not between 0 and 360, it's not really obvious how you draw it. So I have an example here already pre-drawn on the notes, and I will talk about it. I have the angles 90 degrees, which we talked about as the positive y-axis, 450 degrees, and negative 270 degrees. All right, so I want to talk about why these angles are all called coterminal angles, meaning they share the same end spot. Right, they all have the same coterminal, or the same terminal spot. Or point out the same angle. Right. Now it all really boils down to this. I'll read what I wrote in the blue and the green in a second to explain that. But going around in degrees means going 360 degrees around. So if you add 360 degrees to 90 degrees. And so think about being right here at this red line. If we add 360, that's going to take us all the way around from there. And that's exactly what you get as 450. And the 270 is pretty much doing the same thing but backwards, right? If we have 90 degrees but we subtract 360, subtracting an angle means going the opposite way, which is counterclockwise. I have that written over there in a little bit. If we go counterclockwise, it just means go clockwise backwards one way, and that's how you get the negative 270. We take the 90 and subtract 360. So we'd have to take our 90 and subtract 360. And that's where the negative 270 comes from. Okay. So that's pretty much what I have written here in the green and the blue. The 450 degrees is gotten by going counterclockwise. Right? We're going our positive way. One more way rotation, which means 360 degrees more around. Computationally, we add 360 to 90 to get the 450. Right. Negative angles are gotten by going clockwise. So if we start at the positive x-axis, we're going the opposite way. You'll notice once again, for the blue, I have the arrow drawn going the opposite way. Computationally, we get it by subtracting 360 from 90 because we're going to go backwards. We're going to go backwards one rotation. Right, so we say all these angles have the same coterminal angle between 360 degrees, which is 90, because they end at the same spot. So let's just write that in, even though it's kind of written here in a lot of places. Coterminal angles end or point out at the same. You kind of think of it as the same spot, the same direction, whatever wording helps you the most. All of these are pointing towards the positive y-axis direction, 90 degrees. Right. So the way you would figure out a coterminal angle, where an angle actually is between 0 and 360, is you pretty much do this procedure in reverse. Right? When we are given an angle, we're going to either add or subtract 360 over and over again until we land between 0 and 360 for degrees. And that's exactly what I have written here. To figure out coterminal angles, we add or subtract 360 repeatedly until the angle is between 0 and 360 degrees. You may also divide the number by 360, and the whole number that's left tells you how many times to add or subtract. You can do that as well. It's a shortcut, but none of these angles are too big where this is troublesome. Okay. Right, so the directions here will say something like determine the angle between 0 and 360 degrees that is coterminal to the given angle. And the given angle for this first one is 1,956 degrees. What you want to say here is that is much too big. That is way bigger than 360 degrees. So what we want to do is we want to subtract 360 degrees repeatedly until it is between 0 and 360 degrees. Right, this will always work. You can't be bigger than 360 and then the next time you subtract be smaller than 360. So I'll do it that way first in the calculator. We have 1,956 minus 360. Still too big. So we do minus 360 again. That's the way I do it in this calculator. If you just keep hitting enter at this point, after you do this answer minus 360, it'll keep subtracting 360 for you. Still too big. That's still bigger than 360. And finally, 156 is between 0 and 360. So that is our answer. It is coterminal to 156 degrees. If you were also asked what quadrant does this point in, it's not a part of this question, but 156 degrees is between 90 and 180, so it's in quadrant 2. Now, once again, you are not asked that question, so you don't have to really answer that here, but something I want to point out right now. The other way I have written here, it can be shorter. What you do is you take your angle, 1956, divided by 360. And that whole number 5 here tells you how many times to subtract 360. But the way you use that is you do 1956 minus, and then you do 360 times that 5. If you subtract 360 off 5 times, that's exactly what you would do, and you get the 156. So that's another way to do it. Now, when your negative's angle, or your, that's backwards. When your angle is negative, since it's too small, it's smaller than 0 degrees, you have to add 360. Repeatedly. You might only have to do it once. You might have to do it 10 times. And you can also do the shortcut in the calculator, which I'll show you as well. But we got negative 842 plus 360. Negative 482 plus 360. Still negative, right? We don't want negative, so even though this looks like between 0 and 360, it's negative. It's no good. And then we do it one more time. And it's 238. So it is coterminal 238 degrees. And if you were asked this, what quadrant is this in, which once again, you're not yet, but if we were, you would answer the quadrant 3 because it's between 180 and 270. Now, if you want to be careful about, or you want to do it the other way with negatives, so you take your angle that's negative and you divide it by 360. Because it's negative, you're going to add, starting first off. So we got negative 842, and we add 2, the whole number, just like last time, times 360. It's not going to put you between 360 because of the negative thing, so you're going to have to add 360 one extra time. Another way to think about it is if you take this whole number and you round it down. If you always round it down, which means make it negative 3, then you end up adding it 3 times. So there is like a one-off thing when you do with negative numbers. If you do it in your calculator, you'll always get a negative like this. But it's up to you which one you do, which way you do it. Just know what you're doing, why it makes sense. Okay. All right, so to figure out coterminal angles for radians, since going around the entire xy plane is 360 degrees, which is 2 pi radians, we add or subtract 2 pi repeatedly until the angle is between 0 and 2 pi. One thing we'll point out is that, and you'll see this very quickly, if you press that pi button in your calculator, it's going to give you a decimal. And you probably know this trick, but I'll show you anyway. If you try to go back to a fraction, you hit math and this fraction button. If it can be written back as a fraction, it will. But if you ever touch the pi button in your calculator and get a decimal, you will not get back to a fraction and it will not be properly simplified. So we got to work around that, which is what I'll show you how to do. All right, so the first one here, it says determine the angle between 0 radians and 2 pi radians that is coterminal to the given angle. Okay, so the first one here, we got 12 pi over 5 radians. It's got to be between 0 and 2 pi. And the first question you really want to ask yourselves with radians, you might not be very comfortable with them right away. You can just ask yourself, is this actually between 0 and 2 pi or not? Because if it is, it's kind of a trick question, but you're done. It would be itself. And there's a number of ways you could do this. You can straight up type this in your calculator, 12 pi over 5. We get that decimal, compare it to 2 pi. We can see that it's bigger, so it's not between 0 and 2 pi. Another thing you could do is just look at the number and kind of think about the pi being off at the side. If 12 over 5 is bigger than 2, which it is, then it's also not between 2 pi, 0 and 2 pi. But we just checked it, it is too big. The same logic for degrees, if it's too big, we need to subtract 2 pi until between 0 and 2 pi. All right, so I just want to do this visually with this first one because you can do this in your calculator, but like I said, you're going to have to be careful with the pi thing. So visually 12 pi over 5, we want to subtract 2 pi. I'm going to start by, I'm just going to do this one directly by hand and then talk about, doing it in the calculator, because ultimately you're going to want to do that. The numbers don't work too well sometimes. Well, if you want to simplify this as one fraction and combine them, you need to get a common denominator. And this is something you should be well familiar with. Getting a common denominator, we multiply the 2 pi by the opposite denominator, 5 over 5. Then this was 12 pi over 5, because that one already had the denominator. Minus 2 pi times 5 is 10 pi over 5. Once you have the common denominator, then we can subtract them together. 12 pi minus 10 pi is 2 pi over 5. And then you can ask the question, is this between 0 and 2 pi? And this definitely is. It's positive, and it's not bigger than 2 pi. So our answer here is 2 pi over 5. Once again, you can check it. 2 pi is 6.28-ish. 2 pi divided by 5, well, it should be about, this number divided by 5, 1.25. So it works. Right. But another way to think about what we just did, if you want to use your calculator, but you cannot use the pi button, which is understandable, is the following. So if I had to do 12 pi over 5, let me keep this separated, minus 2 pi, if you think about factoring out the pi in the back. So we got 12 over 5 minus 2, and then the pi. Then your calculator is very fine with handling this. You can type this in your calculator and switch it to a fraction. Because when you type that in your calculator, 99% of the time, you're going to be using a calculator that's going to give you a decimal. So I'm going to just type this in, 12 over 5 minus 2. And then if I switch to a fraction, math, frac, get 2 over 5. This gives us, do that in purple, 2 over 5. And then we leave the pi that's from there before I attached on. And that's how we can get our answer. Okay, either one is fine by me. The one thing that like I went through here and I did not do is I did not try to do this in my calculator with the pi button. Don't do that. It won't work. All right, so this one, 28 pi over 3 radians. We want to do the same thing. This is much bigger than 2 because 6 pi over 3 would be 2 pi. So we want to subtract 2 pi. I guess I should say, because this is going to be more than once, many times to get it between 0 and 2 pi. And it doesn't matter which way you do it. If you do it with the calculator, you cannot use that pi button. But I think this is the way, where the benefit of doing it the other way from before, dividing, really helps. So if you take your angle here, 28 pi over 3 and divide by 2 pi, 28 pi over 3. This is going to be a decimal, which is fine, and we divide it by 2 pi. Oops, that's not pi, that's e. Make sure you put it in the parentheses when you divide it, because if not, it'll divide by 2, but then multiply by pi. If you do that, same idea as last time, it's telling you to subtract 2 pi 4 times. So 28 pi over 3 divided by 2 pi equals about 4.7. And this whole number here, just like last time, is telling us subtract 2 pi 4 times. All right, so visually we're talking about 28 pi over 3 minus 4 times 2 pi. Now if you figure out that number this way, then you can do this by hand, and it's not bad because you've already got the number to subtract here, and then you find a common denominator, or you can do the numbers without pi. But you should get 4 pi over 3. Right, 28 over 3 minus 8. Doing the numbers without pi and then switching to a fraction gives you 4 over 3. Okay, so 28 over 3 minus 8 is like that. If you do it by hand with a common denominator, you'll also get that. All right, so there is definitely a benefit to doing the division thing. I prefer that way. But if you don't, then you can just see how many times you gotta subtract it in your calculator, do minus 2 pi over and over again, see how many times you have to do it. All right, the last one, just to be complete, is a negative. We're going to do negative 47 pi over 7 and divide that by 2 pi. I'm going to do it the same way I did the last one. So I take our negative 47 pi divided by 7. Divide that by 2 pi. We got negative 3, so we're going to add 3 times. Because it's negative, we got to add. But you also saw with the last thing, we're going to have to actually add 1 additional time. So we got to add 2 pi 3 plus 1, which equals 4 times. Okay, so we're in the plus 1 from the degree part with a negative as well. And so we got negative 47 pi over 7 plus 4 times 2 pi. Okay, this is 8 pi. I'm just going to do this one by hand. So we multiply the 8 pi by 7 over 7, get our common denominator. Eight times 7 is 56. We got negative 47 pi over 7 plus 56 pi over 7. And then when we add those two together, negative 47 pi plus 56 pi is 9 pi. We get 9 pi over 7. And if you want to check your answer is 9 pi over 7 between 0 and 2 pi, you can do that with the decimals. Is it between 0 and 6.28-ish? Yeah. But if you only add it 3 times, it's still going to be negative like we saw before. All right, so the next main topic in this section is reference angles. Reference angles are a very important topic throughout this class. We'll see them very, very often. The idea with reference angles is that any angle, as you can kind of see depicted here, depending on what quadrant it is, has this idea of a reference angle, which is the angle between its terminal side and the x-axis. Right, so these are the 4 quadrants and their visualization of the reference angle. So if your angle is in quadrant 1, the one on the left here, your reference angle is the angle itself. That's oftentimes it's kind of strange, but people get so used to actually having to do computations when their angle's in a different quadrant, they forget this. If your angle is in quadrant 1, it is the same as your reference angle. But the angle in quadrant 2, just visualize here, if your angle is in quadrant 2, the reference angle is that angle made between it and the negative x-axis. Reference angles are always between it and the x-axis, straight down or straight up. Okay. Quadrant 3, you can see the visualization here. The reference angle is this portion, and quadrant 4, the reference angle going straight up to the x-axis is this portion. And so I got a lot of little things here. You should write down a lot of these because this is where a lot of the issues, especially throughout the class, come into play as not being comfortable with the reference angles. Right, so the first step to figuring out a reference angle is to know what quadrant the angle's in. Because if you don't know what quadrant it's in, you don't know computationally how you're going to figure it out. And if your quadrant isn't between 0 and 360 or 0 and 2 pi, you'll have to figure out its coterminal angle. Excuse me. Now, if an angle is in quadrant 1, like I mentioned, its reference angle is the same, assuming it is between 0 and 360 or 0 and 2 pi. Reference angles are always between the angle and your given axis and your given angle and the x-axis, never the y-axis. Right? So for example, the quadrant 2 angle up here, we would always figure out the reference angle down this way. This angle here, this little section, is not important. Right. Reference angles are acute angles, meaning they are always positive and between 0 and 90 degrees, or if you're in radians, 0 and pi over 2. Right. Reference angles are always acute angles, which is very helpful to know because you probably are familiar with the idea of acute angles a little bit. Right, so they're always between 0 and 90 degrees. My last thing here, mentioning here about the reference angles, that there are formulas out there for calculating reference angles, which it'll depend on what quadrant you're in. If you just draw your picture out, see what quadrant it's in, and you can come up with the formula yourself every time. The problem with trig that a lot of people suffer from is trying to memorize a bunch of formulas when some of them are necessary, but a lot of them are not. These kind of formulas for reference angles are not necessary. You want to get comfortable drawing your axes, figuring out what quadrant it's in, and so on. You'll see that's why I do every single problem like this. That's how I'm going to do it. Right. So the first little bit is just determining the reference angle of the following. Now we got a couple in degrees, a couple in radians, as you see. Right, so the first question to ask yourself is what quadrant it's in. And to answer that question, you really want to know, is it between 0 and 360? Because if it's not between 0 and 360, you probably won't be able to visualize that it's in. All right, and for 0 and 360, of course, I'm referring to degrees here. If it's in radians, we're going to ask 0 and 2 pi. So is 247 between 0 degrees and 360 degrees? Well, that's definitely a yes. Right. And what quadrant is it in? Now, naturally, if you don't have this memorized already, because you just started this class just watching the videos, that's understandable. To figure out your quadrant, draw the XY plane, but draw the angles on the axes. So remember, this is 0 degrees. Then we go up to 90. Then over to 180. It goes up by 90 every time. Then 270. And then 360. Oops. All right, and you can see since it is between 0 and 360, we can draw a little section for it. It's between 180 and 270. Just kind of draw something in there. It doesn't have to be very precise. But we could say 247 is somewhere like this. It's in quadrant 3 because it's between 180 and 270. Okay. All right, so we got that. The next thing, if you want to figure out the reference angle, is remember what we said. The reference angle is the angle between the terminal side and the direct x-axis, meaning it is this angle right here. This is where the reference angle is. Right, the reference angle is always between the terminal side of your angle and the x-axis. But over here, that's 180 degrees. And the way you compute the reference angle is always the bigger minus the smaller. So this time the bigger is 247, the smaller is 180. Okay, so the reference angle, bigger angle minus the smaller angle. That's because it's got to be positive. We got 247 minus 180 equals 67. All right, so our answer here, the reference angle is 67 degrees. Right. So degrees, especially degrees between 0 and 360, are relatively quick once you practice some. The next one, number 2 here, you'll see we don't have the first question answered. Is it between 0 and 360? So we gotta make sure we do that. Right, so is this between 0 and 360 degrees, negative 144? The answer to that is no. So we gotta make it between 0 and 360 by finding its coterminal angle. All right, now for this one, you can probably see, hopefully step 1, you see that you should add 360, not subtract, because it needs to get bigger. And if you add 360 once, it's going to become positive. So that's all we have to do is add it once. Negative 144 plus 360 is 216. Right, once it is between 360 degrees, then we want to answer the question, what quadrant is it in? And for every time you want to answer the question of an angle, what quadrant is it in? You want to draw your picture. We got 0 degrees. It's the same one I just drew above, but I'm going to redraw it for emphasis. 90, 180, 270, and 360. And just once again, with degrees, you can pretty directly ask the question, which one does it fall between? It's between 180 and 270, so we have another quadrant 3 angle. Once again, I'm not drawing it any specific way, I'm just drawing it in the correct quadrant. And the way I would compute this reference angle, exactly the same. We're looking at it here. The two angles made between it to make it are 180 and 260, and the reference angle is the bigger minus the smaller, 216 minus 180, which is 36. Right, so our reference angle is 36 degrees here, and you can see both the answers we got are acute angles. It doesn't guarantee that they're right. You got to actually do everything correctly here, but whenever you do something like this, if you mess up, if you add or subtract the wrong thing, if you do it in the wrong order, if you find the wrong coterminal angle, you're almost always going to not get an acute angle. So it's pretty helpful. All right, number 3, we have radians. Right, so once again, we want to start, just because it's a radian doesn't mean we ask any different questions. If we want the reference angle, we first start by asking, is it between, for radians, 0 and 2 pi? Right, and just like we talked about above, there's a number of ways you can figure that out. You can type this in your calculator and compare it to 2 pi. You can notice that 11 pi over 6 is smaller than 12 pi over 6, which means it is between 0 and 2 pi. Now, once it's between 0 and 2 pi, then we ask ourselves, what quadrant is it in? And this is probably where you're a lot less comfortable initially with the radians than degrees, is because of the pi there. It's not whole numbers. So I want to talk about that, but make sure you draw your angles in on the axes. 0 radians, it's pi over 2, then pi, then 3 pi over 2, and then 2 pi. And you want to see which one it gets shoved between. Now, when we do our computation, we have to use the 11 pi over 6 in the correct angle on the axis, x-axis. But if you want to see which one it's between, you can always just compare 11 pi over 6 to the decimal approximations. So pi over 2 is about 1.57, pi is about 3.14, 3 pi over 2 is about 4.71, and 2 pi is about 6.28. So you can really ask your question, typing in this calculator, which pair of numbers is it between? Is it between 0 and 1.57, 1.57 and 3.14, 3.14 and 4.71, or 4.71 and 6.28? So type it in your calculator, 11 pi divided by 6, and we get 5.76, which would shove it in quadrant 4. It's between 4.71 and 6.28. So I'm just going to draw that in, but one thing I will, as you see, I use some decimals here, but you need to use the actual angle with the pi's. Do not round, do not get rid of that pi ever unless if your answer says you can round your answer at the end. I'm just doing this for a placement. Now visually our reference angle is between the angle and the x-axis, so it's this right here. And thinking about being counterclockwise, that means it's pointing this way. Now the quadrant 4 is the one most people at first mess up on, because the question arises, do I do 0 or 2 pi? Well, it always points to the bigger angle, which means whatever I do here is going to be the bigger angle. And 0 minus 11 pi over 6 is not going to give me an acute angle. We have to do 2 pi, oops, not over anything, 2 pi minus 11 pi over 6. Right? It's always bigger minus smaller. And you do it in the opposite order. You see, when we do this out, you want to simplify it without using your calculator, or at least without using that pi button. We will get something that's acute. All right, so let's go ahead and simplify this. If you do it by hand, get a common denominator, multiply by 6 over 6. And this is 12 pi over 6 minus 11 pi over 6, which is 1 pi, or just pi over 6. Okay, so that is our answer, pi over 6. Right, now this is the only correct answer to this. You cannot get this as a decimal. You cannot use decimals at any point. We just use the decimals here as a reference of what quadrant it goes in. And that's one way to do it. Right, but you can check if you're not comfortable with them yet. Is pi over 6 acute? Well, it's positive, so that's good. Is it between 0 and pi over 2? Yes. Pi over 6, 0.523-ish, is definitely between 0 and 1.57. So this is acute. All right, so the last one with radians here. It's definitely an angle that's not between 0 and 2 pi, 123 pi over 10. So we got to do that. And that's why we already talked about this coterminal stuff first. So we take our 123 pi and over 10, and how many times are we going to subtract off 2 pi? We can look. Here we did 123 pi, the angle, and then divide that by 2 pi. And we get 6.15. We're going to subtract it off 6 times. All right, this is 12 pi. 123 pi over 10 minus 12 pi. And if we get our common denominator, multiply this by 10 over 10. This is 120 pi. So 123 pi minus 120 pi is 3 pi over our common denominator of 10. And so that is our coterminal angle. This is the one we use. What quadrant is 3 pi over 10 in? If you draw the picture once again and use decimals, that's fine. Got 0, pi over 2, pi, 3 pi over 2, and 2 pi. What we want to do is compare it again. If I type in 3 pi over 2 just to get that decimal. Whoops, wrong one. 3 pi divided by 10. 0.942, which would put it in quadrant 1. And because this is about 1.57, so it's between 0 and 1.57. It's in quadrant 1. But once again, use the angle with the pi. Computationally, we're looking at the angle between here and the x-axis right here. Now, if you remember from before, if an angle is in quadrant 1, its reference angle is the same. And the reason it's going to be the same is we're going to have the bigger one. Bigger of the angle is 3 pi over 10 minus the smaller angle, which is 0. And subtracting out 0 does nothing. So that's why reference angles in quadrant 1 are the same as their coterminal angle. So our final answer here is 3 pi over 10. Right, and as far as reference angles go, pretty much everything in this section without the radian angles without pi, we've covered. Well, actually, I correct that. There is one other topic to give you a little more practice with reference angles. All right, so the next topic related to reference angles is very, very important. Most of the time we're dealing with reference angles, it's not just figure out the reference angle, it's you're going to figure out the reference angle and then give me an angle in another quadrant with that same reference angle. Okay. So what the following questions are going to be, for the following questions, you are given an angle in a quadrant. For the given angle, determine its reference angle, and then find the angle between 0 and 360 degrees, or 0 and 2 pi, in the given quadrant. That has the same reference angle. All right, so what this number 1 here is asking us to do is we want to figure out the reference angle for 187 degrees. Then we want to, with the quadrant 4 information, we want to give the angle in quadrant 4 with that reference angle. All right, so we're going to figure out the reference angle for 187 degrees like we did before. Then with that, we are going to figure out the reference angle. The angle in quadrant 4 with that same reference angle. And so 187 degrees is between 0 and 360. So it's going to be on here. All right, and 187 degrees is in quadrant 3. We have that drawn, and then if we visualize where our reference angle is right here, our bigger minus our smaller, 187 degrees minus 180 degrees is 7 degrees. Right. And these homework problems are 2 steps. You have one answer box for this. You would put in 7 degrees as your first, or just 7. The degree symbol will be attached. You don't have to figure out how to type that in. And now we want the the angle in quadrant 4 that has with a reference angle of 7 degrees. All right, so visually what we're saying here is draw an angle in quadrant 4, just right here. And we want its reference angle to be 7 degrees. Okay. So the way we can figure out what our angle here is, our orange angle here, is kind of think about the opposite way, right? So we know the angle it's going towards is 360 degrees, and it's 7 degrees behind it. Right, so kind of putting in words, what we have here is 7 degrees behind. That's not how a B looks. (360 degrees). Remember, the reason we say behind is because positive is counterclockwise. So we are behind 360. We are going backwards. And if you think about exactly what that means, just think about when you learn subtraction, you would say, well, if I'm talking about being behind something, I'm talking about subtracting 360 minus 7, which is 353, is that angle. And so 353 degrees is the angle in quadrant 4 with a reference angle of 7 degrees. Right, so those are the two answers here. All right, number 2 is just to practice an additional one with a negative angle, because I don't think we even did. Actually, did we do a reference angle with a negative angle? We did, so we're comfortable with that idea. But we want to figure out the reference angle of negative 48 degrees. And then upon doing that, we want the angle in quadrant 2 with that reference angle. Right. A really good mindset in dealing with these problems on the homework is to think about it as 2 questions. Right. The first question, reference angle, don't even worry about the quadrant 2 thing yet. Get that reference angle. Then we'll use the reference angle we get. When we're dealing with degrees here, I'm going to draw my picture again. And this is not between 0 and 360, so I'm going to add 360 degrees to it to get it between 0 and 360. And 360 plus or minus 48 is 312. So it's in quadrant 4. Our 312 degrees, our initial angle is in quadrant 4. And our reference angle here, right? Just remember, once again, be careful. Don't subtract the wrong thing. It would be 360 degrees, the bigger one minus the smaller one. 360 minus 312 is 48. Right, so the reference angle for negative 48 degrees is just 48 degrees. All right, and that it would be the first answer that we're dealing with. Right, now you saw, if you rewind or look back up in your notes when we did the other angle here, that was negative reference angle. Its reference angle was not just negative of that, getting rid of the negative sign. So don't think that for reference angles with negatives, you just get rid of the negative sign. You gotta do it the way we've done it. Okay. So now in quadrant 2, we want the angle in quadrant 2 with a reference angle of 48 degrees. Okay. All right, so just draw a generic angle in quadrant 2. Right, nothing specific, but the only thing we know right now is that our reference angle, so the angle between this and our x-axis, should be 48 degrees. Right, now think to yourself, how should we compute this angle? Well, our orange angle here is behind. It is behind 180 degrees by 48. So this would be 180 minus 48, which is 132. So the second answer here is 132 degrees. These problems use pretty much everything we did in this section besides converting between the radians and degrees. But they're really important going forward. So what I want to do now, we just have a couple more with radians. I'll go ahead and mention that both of these are between 0 and 2 pi because as you've seen, just even doing the reference angle part by itself with between 0 and 2 pi and the coterminal stuff can be quite a lot, and I don't want to put too much on you on the first section. All right, so the next one, we have the angle 3 pi over 4 radians. It's going to remind you what we are doing here. We want the reference angle for this. And then after we get that, we want the angle in quadrant 1 with that reference angle. Right, and like I mentioned, you want to check this, but it is between 0 and 2 pi. 3 pi over 4 is between 0 and 2 pi. We draw our picture. We got 0 and 2 pi over there. We've got pi over 2 at the positive y-axis, pi at the negative x-axis, and 3 pi over 2 at the negative y-axis. Now if you compare where 3 pi over 4 is, it is in quadrant 2. It is between pi over 2 and pi. And visually, our reference angle is right here between 3 pi over 4 and pi. We do the bigger minus the smaller. Our reference angle is pi minus 3 pi over 4. Get a common denominator, pi, multiply by 4 over 4. We got 4 pi minus 3 pi, which is 1 pi over 4. And so the reference angle for 3 pi over 4 is just pi over 4. Like we talked about when we did reference angles with radians, you gotta leave the pi there if it's there. Don't use decimals for anything other than comparing. Right. So now we want the angle in quadrant 1 with that reference angle. And so we want the angle in quadrant 1 with the reference angle of pi over 4. Drawn in the brown here. And the thing you want to realize If we want the angle in quadrant 1 with referencing of pi over 4, it's pi over 4 past 0. Because it's going past 0. We wouldn't want to go past 2 pi, even though it wouldn't be between 0 and 2 pi. We want to say it's pi over 4 past 0. So the angle here in brown is 0 plus pi over 4, which is pi over 4. Okay, so the angle in quadrant 1 with the reference angle pi over 4 is pi over 4. And just one more here. Just like to have a lot of combinations just so you can see a lot of them. It's good to have extra practice with a lot of the stuff in this section. We want to figure out the reference angle for pi over 6. And then we want to figure out the angle in quadrant 3 with that reference angle. Okay, so pi over 6 is definitely between 0 and 2 pi. And if you compare it to all of our axes values here, you will get pretty quickly it's between 0 and pi over 2. Pi over 6 is between 0 and pi over 2, so it's in quadrant 1. And the reference angle visual here, bigger minus smaller, pi over 6 minus 0 is pi over 6. All right, so answer to the first part of this question, pi over 6. Second part of the question, what angle in quadrant 3 has a reference angle of pi over 6? Quadrant 3 is down here. Draw our picture. We want the reference angle to be pi over 6, the same thing. So coming from the x-axis towards it is pi over 6. And what you want to notice about this one, this angle here, is it is past pi, right? Going counterclockwise, it is past pi by an angle of pi over 6, which means our angle is pi plus pi over 6. Right? It is past pi, so we're going beyond it. We are adding. And if we simplify pi plus pi over 6, get a common denominator of 6. 6 pi plus pi is 7 pi over our common denominator of 6. So that would be the angle. Now, as far as the rest of the section now, I can stand corrected myself. The only thing left to do is talking about reference angles with radian angles without pi. Really for this, what you'll see is you have to use the calculator when there's no pi. And you only have the actual decimals to compare to. Okay. So there's not too much in this, but I do have a few homework questions about it because this is so important going forward. But like I said, often radian angles have pi attached to them. However, we will often use decimal approximations to radians, which will not have a pi in them. Remember, an angle is in radians if there's no degree symbol. It doesn't matter if there's a pi in there or not. All right, please note that the process will be the same, but we will be very dependent on our calculator when we do these. And here I just have those numbers on the x and y axes filled out for the angles. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Just to give you a gauge of where your angle might sit. Right, so I've got two problems here that are like the ones we dealt with at the end. So for the following questions, you are given an angle in radians and a quadrant. For the given angle, determine its reference angle. Then find the angle between 0 and pi over 2 and the given quadrant that has that same reference angle. All right, so we want the reference angle for 4 radians. And it really seems so weird to write just 4 without that degree symbol because there's no pi there, but that's just it. Right, so what I'll do is I'll draw the axis, but since we're comparing to the decimal, I'm going to also include the decimal in there because I have to talk about that. So pi over 2 was about 1.57. Pi, which is about 3.14. And 3 pi over 2, which is about 4.71. Okay. All right, so this is in quadrant 3, right? It's between 3.14 and 4.71. Our angle is 4 here. Once again, you just write 4, but there's no degree symbol. Everything visually, everything by definition is the same. Our reference angle is right here. And you do the bigger minus the smaller. Our bigger angle is 4 minus the smaller. But what you want to be careful about is, once again, these decimals are only for approximation purposes. You still want to use pi in your calculator, but we are very dependent on that. So let's go ahead and type in 4 minus pi in our calculator. You get 0.85841. Whoops. I don't have the greatest memory. 0.85841. Right, now in the directions you'll be told how far to round. I left this obscure because the directions just vary. If you have to round to a certain spot, go at least one spot further than you have to round. Right, that's pretty much always a safe thing to do. Sometimes it might even be safer to go 2 or 3 spots further than you have to round. But the reason you don't want to use the number like 3.14 is it's automatically going to round it to 2 spots, and that might not be far enough. But our reference angle for the angle of 4 radians is 0.85841. If you round farther than the question says, that's quite all right. It'll still accept it. Now we want the angle in quadrant 2. With a reference angle of this. With a reference angle of the 0.85841. Right, so quadrant 2 is right here. Draw our angle here. And the reference angle is the same from above, the 0.85841. Now, if you compute this angle, you still do think about it being 0.85841, this number behind pi. But once again, you use the pi. You do not use 3.14. So we got pi minus 0.85841. And if you do that in your calculator, we get 2.28318. And once again, however far it says to round, since this is the final part of your answer, you can round here, but you can always round too far. If you at any point don't round far enough, you cannot make that up. So just round too far, type in your answer to too many decimal places, it'll be correct. All right, but dealing with angles in radians without pi, it really isn't that big of a deal. It's just you really have to remember, don't use this 3.1 for, use the actual pi, and so on. All right, so number 2 here, we've got negative 1.3 radians. We want the reference angle for this. All right, this isn't between 0 and 2 pi, so we got to fix that. But once we figure that out, then we figure out the angle in quadrant 3 with that reference angle. All right, so like I mentioned, this is negative. It's not between 0 and 2 pi. What we would have to do to get it between 0 and 2 pi is add 2 pi because it's too small, it's negative. Right, so negative 1.3 plus 2 pi. Once again, you're using your calculator, but you want to use 2 pi. You do not use that 6.28 number. You have to use the pi. And once again, round too far. However far it says to round your final answer, just round that too far. We get 4.98319. 4.98319. This is between 0 and 2 pi. Let me not use that red color because I'm using it for the other part. Okay, and let's go ahead and fill in those numbers. 2 pi is about 6.28. Pi over 2 is about 1.57. Pi is about 3.14. 3 pi over 2 is about 4.71. And now comparing our angle, we can see it should go in quadrant 4. It's between 4.71 and 6.28. Now what you want to do here, since you already had to round, don't round the angle that you're using. 4.98319. As long as you've rounded too far, your final answer will still be fine as far as the rounding goes. Right, so visually our reference angle looks like this. We got to make sure that with the bigger angle here, we use the 2 pi, don't use the 6.28 minus our 4.98319. So one thing you can do on this calculator, which I didn't do in the first one, but if you want to just use this whole number, instead of typing in what I did before, you can hit second and the answer, and it will type this in. So it's 2 pi minus this, and you get 1.3 back. All right, so the reference angle for negative 1.3 is 1.3. And we want to finish up, we want the angle in quadrant 3 with a reference angle of 1.3. Since this angle is 1.3 past pi, All right, once again, when I say past pi, we're thinking counterclockwise is positive, so we're going past pi. We got pi plus 1.3. And if you do pi plus 1.3, or do your answer thing again, we get 4.44159. And that is how we deal with angles with radians without a pi. Right? If you ask the coterminal angle, we did it in this one right here. If you ask for a reference angle, we did it in each of these two. The coterminal angle was the getting between 0 and 2 pi part. So, really emphasis on don't be scared of angles with radians without pi. Just do understand that you do have to use your calculator for them. There's really no way around it. You're going to have to make use of that, and make sure you use the actual pi's when you deal with all this stuff. As long as you round too far, you'll be fine. All right, but this is our first section on angles. There's a lot of stuff in here. This is the longest section we do all class, besides the very last one, actually. They're about the same length. But all the stuff we do in this section is very, very foundational. I am not giving you any useless, needless questions in here. These are all very important to what we do throughout the class.